Last episode, I told you that an LLM predicts the next word. That was a small lie, or a useful simplification, because the model doesn't actually see words. It sees something stranger. Here's what one tokenizer might see when you type the word unbelievable. Not one word, 4 pieces. Un-be-lieve-able. Each piece is called a token. A token is a chunk of text the model treats as one unit. Sometimes it's a whole word. Sometimes it's part of a word. Sometimes it's a single character. Different models split text differently, but the idea is the same. The model receives tokens, not neat human words. Common words are often one token. The, cat, run, house, internet. If a word shows up a lot in the training data, it usually gets its own token slot. Less common words usually get broken into pieces. Long words, rare names, accents, emojis, numbers. All of these can split in ways that feel strange to us. Numbers are a great example. The number 12,345 might end up as 2 tokens, or 3, or 5. Different tokenizers handle digits differently, and the model just learns to live with whatever it gets. The same word can tokenize differently based on the space before it, or whether it's capitalized. Apple, with a leading space, is 1 token. Without a space, a different token. Capital A versus lowercase a, different tokens. The model treats these as essentially different things. And tokenization varies a lot by language. In English, 1 token is roughly 3/4 of a word, but in many other languages, the same meaning can take 2 or 3 times more tokens, which means a non-English speaker hits context limits faster and pays more for the same idea expressed in their language. Why does this matter for you? First, context windows. When you hear that a model has a 128,000 token context window, that's about 96,000 English words, not 128,000 words. The token count is always larger than the word count, because punctuation, spaces, and word fragments all count. Second, pricing. If you use these models through an API, you pay per token. Every word you type, every word the model writes back, every space, every punctuation mark, counted. Third, and this is the fun one, tokenization explains some of AI's weirder failures, like, why have some chatbots stumbled when asked how many R's are in strawberry? One reason is tokenization. The model may not naturally see the word as 9 separate letters. It sees chunks like straw and berry, and has to infer the letters inside them. Each model comes with its own tokenizer, chosen or built before the model is trained, then fixed for that model's lifetime. You can't change it after the fact. Words the tokenizer encoded as single units stay single tokens. Rare combinations stay fragmented. So here's the real picture. The model takes your text, chops it into tokens, predicts the next token, then the next, then the next. Predict the next word was the simple version. Predict the next token is the precise version. Different models tokenize differently, but the principle is the same. Next episode, we'll look at where the model gets its judgment about which token comes next. The model figures it out by reading enormous amounts of text, public web pages, licensed data, human-written examples, and getting its guesses slightly less wrong, trillions of times. That's training. If this was useful, subscribe. It tells me to keep making them. See you next episode.